So to survive this talk, you do need a drink. Doesn't have to be beer, doesn't have to be alcoholic. You just need a drink because there's a lot of it.
Stay hydrated.
Stay hydrated, always important. Okay. So the topic of this meetup, or of this talk at least, is supposed to be testing. And it's a very wide topic, so we kind of sort of assume that since it's going to be a more intimate setting and it's easier to share a screen and do something other than just talk, said the person just talking, we're going to do a more practical session. So I would like to sort of, in a second, I'll share my screen and I'll hopefully write some code and talk a little bit about the testing, how to integrate it, and we'll first see a more of a trivial example, and then later on we'll sort of see how that translates into a real life example with a more complex code, so you don't just see a test that 1 + 1 = 2, because those are typically boring. If in any time you have a question, I think it's okay to just unmute yourself and ask. If you're not comfortable with it, just ping it into Slack, and Aleš or Kubik, I would ask you, if that happens, to just read that question out loud for me, because I won't have the opportunity to check the chat. Thank you very much. And by all means, ask all the questions. As everything, as any demo or anything, it's always better to have this interactive. So let me share my screen. And here, do you see my terminal window?
Yeah, totally.
Okay. So we need to wait for the train to pass. And then what we're going to do is we'll create our own, our first code. So what we have here is just an empty Python file, and we'll create some code. When I was thinking about what to do, I thought back to the pair programming sessions that we did at PyCon that some people liked. So we're going to do a game of life. So that's a well-known problem called Ways Game of Life, and the idea is fairly simple. Essentially, you have a playing field, and in that playing field you have cells that are either alive or dead, and then based on the neighborhood, from one step to another, they either survive or die. Relationship to the current situation is purely accidental, but let's get into it. So the first thing that we'll do is we'll write some example functions. So I will start with a function that's called getNeighbors to get all the neighboring coordinates of a given cell. This is something that I prepared beforehand, so I can actually type this really fast. And let's go through that code a little bit. So this is the code that we have for now. Essentially, given a coordinates x and y, which are just integers, we want to see all the 8 neighbors around that one cell. So this is how you would do it in Python. You just say, you just ask itertools for all the combinations of -1, 0, and 1, the length of 2, and hopefully this will generate all the different steps. But how do you actually make sure that this is the case? Well, the easiest way is to write a test. So for every function, we will have a test function as well. So we'll just call it test_getNeighbors. Doesn't need any parameters or anything like that. And here, what we're going to do is we're just going to be using assert. So assert, which you can see immediately that it changed color, are essentially, let me actually make this bigger because we don't need the whole width. Okay, so assert is a statement. It's a built-in thing into Python. It's not a function. It's not something that you can redefine, and it essentially is telling Python that I assume that this is as it is. If it's not, if my assumption is not correct, just raise an exception, just throw up. So in this case, what we can see, what we can start making our assumptions into how our code works. For example, we can say that 1 and 1 is somewhere in the neighborhood of 0, 0. So let's save that. And now we just need to run the test. So we need to make sure to actually execute this test. And let's start right away by saying that we can do this because we have this file here. And we will first do a pip install pytest. So pytest is a Python library that is a utility to run tests and also provide some different helpers. Now, if I run pytest, it says that it collected one item, so it found one test, and that test passed. I see that one test passed, and it took 30 milliseconds. So what happened here? So first of all, the pytest actually went on and found any file that has a test in its name, and then in that file, it actually went in and found all the functions that start with test underscore. So in our case, it found this function, and it passed, which means that all of it sort of executed successfully. There was no problem, which means our assertion passed. So let's add another test. Now, normally, or should I say correctly, I should have a separate test for each different assumptions that I make. However, in real life, that is not really practical. So what I'm going to be doing is I'm just going to put in more asserts. For example, 2, 1 is not in the neighborhood of 0, 0. Again, I save this, and I run the test again. That is perfectly fine. Tests are still passing. Now I will write another test. Let's say that a cell is not its own neighbor, right? That's reasonable. So essentially, all I'm doing here is trying to come up with the different things how things could fail, or the other way around, different things that I absolutely need to happen, that I need to be sure of. And here I see that this finally failed. So I see one failed test, and this is the part that failed. It highlights it in the function, and it even says that 0, 0 is not in whatever's on the right side. So what do I do here? So there are different options how to debug this. I could easily say to the pytest, to whenever this happens, to drop down into the debugger and do other things, or I could have my ID set up to do things. In my particular case, like let's not look at ourselves. This is an easy example, because what we have here is we're generating all the different combinations. So not just the neighbors, but what we will include here is the 2 double zeros. So we kind of have to say that if A and B is 0, 0, then don't count that. And let's see if this fixed our, great, this fixed our test. So this is the primary methodology of how you use tests. You just keep adding different conditions that you can think of, and whenever you get a surprising result, so a test fails, or maybe a test passes that shouldn't have passed, then you go back and you try to, and you know that there is something to be fixed. And this is deliberately very vague, because the tests, they don't know, or they cannot tell you what to fix. They just tell you what went wrong. but you can be more specific. For example, here I can say I can always, the assert takes two arguments. One is a condition, so anything that you would put in an if or anything like that, and the second one is a message. So I can say cell is shouldn't be its neighbor. And now, if I make sure that this still fails, what I'll see is it actually tells me what went wrong. So if I know what I'm testing, and that could be either the name of the test, because you see that here I have the name of the test, or it could be literally just a custom message for the assert, then I know at least what went wrong. I still don't know how to fix it, because if the test knew how to fix it, we wouldn't need programmers anyway. So that's not really the goal here. The goal here to be able to first identify that there is something wrong, and more importantly, figure out that whatever I did didn't break anything. So for example, if I did this, I know that I fixed this test, but also that the other tests that were already there are still passing. So if I made an error here, and we'll do something like this. Then I know that I've broken something. The change that I introduced has actually broken something. So having tests gives me the confidence of changing the code and knowing that whatever tests I had, if they're still passing, that's the functionality that I didn't break. The wording of that is quite deliberate, because it doesn't tell you that the code works. It just tells you that the tests that you have still work or still pass, meaning that whatever assertions, whatever assumptions I had about the code and how it works that I put down as tests, they're still valid. They're still there. Does it make sense? Any questions at this stage?
I mean, fine. Can you just quickly, for people that are new maybe to PyTest, can you just describe what part of the thing that you just described are tests in general? What part are PyTest specific? How assert is different from if statement maybe? I don't know.
Thank you. So right now, as you can see in my code or in my test, I'm not really using PyTest. I'm just using it to run the test. So literally just to find all the files that have test in their name, and then in those files find all the classes and all the functions that also represent tests. In my case, it's this function here. So you see, even though I have test function, two functions, PyTest correctly identifies that only one of them is a test. If I had this function multiple times here, now we'll have two tests. So this is right now all that PyTest is doing for us. It's finding the files. You notice that I'm just running PyTest. I could give it the file, but if I don't give it the file, it will just find all the tests all the files, that start with test underscore. And it does the same inside of those files. So right now, I'm just using it for a limited functionality to run the test. I might as well, it would actually be the same thing if I did something like this. And now I can actually run it, and it will again run the tests, meaning that if I have a problem here, I get my assertion error. But as you can see, it's not as pretty. You don't get the information about how many tests there were, and you don't get many of the different things. That's why you always have a test runner, something like PyTest. There are, of course, Python runners built into Python itself as well. But in my opinion, the PyTest is much friendlier because it allows you to do things very simply, just using the asserts, just using functions, and keep things simple. So the code, including the test, is pure Python, nothing specific about it. But the way we run it, that's where we use PyTest to actually find our tests and execute them. And of course, PyTest has many other different features that we'll go into details later. So far so good. Okay.
Okay.
So let's move on. And so the next things that we can do is oftentimes we have something. Obviously, this is a trivial test. This is a trivial test for many reasons. The main one is we are just testing a pure function from sort of the definition of that word. The get neighbors has two arguments, which are very simple, just two numbers, and it doesn't do anything else. It doesn't reach out to an external system. It doesn't have any side effects. It doesn't need any configuration. It's the simplest thing that you can test. And that is super important. It is super important because here in our test, we don't need to initialize anything. We don't need to create anything. And also that sort of shows you how best to structure our code so that it's testable. For example, let's say that we do something more complex. Let's say that we have what can we do? Let's say that we want to download something. That's a test that would require us, for example, being connected to the internet. So that's not great, right? Because that test won't work everywhere, and sometimes if you run it on your company's network, maybe that URL would be blacklisted, and you might get some different noise. Or you might get a test that uses a database. For example, let's actually create a function like that. So I have what do I have? I have Elasticsearch running, so I can say give me a function that will test whether Elasticsearch is alive or not. So we'll say. So this is my function, and what is it going to do? So in real life code, I could do something like that. So I will import my library, and I'll instantiate a client, and in my code I'll just say return es.ping. Right. And here we can kind of say, again, we'll create a function. So def test ping yes. Okay, but what do we do here? Because we have, let's say that we do something here where we say hosts. We'll say production.es. So this would be a test where I'm saying that Elasticsearch should be alive. But the problem is that here I'm connecting to my production Elasticsearch because that's really what I want to have in my code. So I have two different options. First is to have some sort of configuration or something like that. Or the easiest one is I will actually create my function so that it doesn't use some sort of global variable es here, but instead will rely on getting the instance to Elasticsearch from the outside. So here we can kind of say, here we can create our own and pass it in. So now when we run the test, oh sorry. we see we have two tests and they both pass. If I changed it how I had it before, this will not work, because we don't have access to production. So this is one approach how to do it, and it sort of leads us to structuring our code so that it's better, so that it's more modular. So if you try and make your code easier for you to test, then it will be better structured. So here we can do something like this. And admittedly, this is a much nicer piece of code. It's much cleaner to read, and it's easier for people to work with. And the way we arrived at it is not by years of experience or anything like that. It's just the laziness. How do I test this? If you think about how do you test this, you will be facing a lot of the same problems that you might be facing in production. For example, what if it happens that in production you would have different databases or different hosts if you want to configure it? How do you do it? It's kind of the same problem that you're facing here in test. So if you make it easier for the test, it will then be easier for the production as well. So sort of to extrapolate from that, if you structure a code so that it's well testable, it will be better code. It will be more modular. It will be more flexible. So that's sort of always a little bit of an unintended consequence of testing. Make sense? Any questions for that one? Okay. And now to sort of show you some tips and tricks. So in this case, what we have here is we have the Elasticsearch client that we kind of need to use, and we need to get it somewhere. So it would be ideal if we could kind of sort of don't have it inside each and every test. So what we can do is we can finally start using our PyTest. And PyTest has something that's called a fixture. So what fixtures are, they're essentially a prepared configuration or state or any kind of piece of code that you're going to be using in your tests. So in my case, I'll create a fixture called ES. And all that will do is it will create a new instance of the Elasticsearch client. And now if my test has an attribute that's called the same as a fixture, PyTest will automatically call this function, get the result of it, and pass it in. So in this case, we should still see the test passing. Yes, we're constructing a valid client for Elasticsearch, and we're automatically passing it into the test. And we can do other things as well here. For example, we could have fixtures also using other fixtures. So we could have a fixture called host. So we could have fixtures using fixtures. So still everything passes. And the most sort of interesting bit here is we can have fixtures do some sort of prep work and finishing work. So here we can do create a client and give it out, return it. But then after it has been returned and after the test ran and did with it whatever it needed to do, we can do other things. So for example, in this case, we can say delete all indices. So assuming that our test here might have to create some data. For example, es indices.create. And obviously this alone would be a very bad test. Why is that? It's because this test does something to the real world, to the Elasticsearch that we're using. It creates an index. In this case, doesn't matter what Elasticsearch is or what index is. It just does something that exists outside of Python. So if then another test ran, it would have a changed outside world. It would have Elasticsearch, which already has an index. So what we need to do is make sure that after the test is run, we clean up after it. In this case, the cleanup consists of deleting all the indices. So no matter what any test does, so for example, we could have another test here, test index doesn't exist. It needs access to Elasticsearch, and it will say assert not yes indices exists index A. So now we have tests. We have 3 tests, and all of them passed. But if I didn't have this bit here, it would depend on the order in which the tests are run. So if this test is run first, it will work because the index is not there, but then it is created by this index. So then if that were run in another order, then it wouldn't work. And that's a very bad thing for tests. Tests need to be, the technical term is idempotent. They need to be able to run in any conditions exactly the same. They need to be independent of the outside world. They kind of need to control everything. So in this case, that's what we're using this fixture for. So fixture is a way how to prepare state. So absolutely whatever you need for your test to run, and then possibly also clean up after the test. That way, your individual test can just focus on what's important and doesn't have to have any kind of awkward pieces of code to set things up and then delete it after. Does this make sense? Cool, no questions. So I also promised you a real life example. So by the way, don't worry about getting all of this or not getting all of this. This is more of a inspirational talk about what are the things that are possible. I don't expect you to remember this or be able to reproduce it. It's more to know how to properly think about tests and how to use them. The individual tools, there are many different tools that do kind of the same thing. The important part is that you always just test your code. You can kind of think about your code, whether it's a test or real application code, as a sandwich. So you have the 2 pieces of bread that are boring, and the important stuff is inside. And the goal is to abstract the things that are repetitive, and so that your code itself can focus only on the important parts. So you can see here, I'm not concerned about how I create the Elasticsearch client. The same way as here, I'm again not concerned about that. I'm also not concerned about what happens to my changes. I know that somebody else will clean it up. And this is my bread part. So this is how I create the Elasticsearch and all of that part. This is infrastructure. This is a code that allows my tests to run. These are my actual tests, and this is my actual code. So that's the important part. That's how you want to think about it. Whatever is just sort of, yeah, I need to do all of these things just so that I could call my function. That's a fixture. That's a setup. That's this part. I need to create a client. And then of course, I also need to clean up after myself. So the next test that comes after me is starting in the same position that I started. Or if I try to call this test multiple times, it should run. It should succeed. In this case, without the cleanup, it wouldn't, because it creates the index the first time, but the second time the index is already there. And so of course we can show you that. And if we just have the simple fixture that we started with, now this will fail. So right now it fails in 2 tests, well 3 tests. You see 1 pass and 3 failed. Again, the problem here is that the previous test that we ran didn't clean up after itself either, so we're not starting from scratch. So that's the crucial part. You need to always make sure that you start from the same point. For example, right now, if I actually fix the fixture, this will still fail. And it fails because the first time it runs, it doesn't start with an empty Elasticsearch. It's not something that the tests have done. It's just when the test started running, the Elasticsearch cluster that I'm testing against still had some leftovers from the previous time I ran the test. Again, something that I cannot afford. Right now, when I have the proper fixtures in place, I can run this again and again, and it should always work, because it always comes from the same point. Every time this test runs, it sees the different world. There are no differences to it. Okay, and for my last trick, I will actually show you how this is done for real library. So I chose Elasticsearch because that's what I do for a living. So this is, for example, all of my fixtures that I use in the official Elasticsearch client. I have a fixture here that tries to create a client, and you can see a few things here. First is there is this part. There is the skip. So what I can do here is kind of tell PyTest that, yeah, I'm trying to do this thing, but it doesn't work. So don't worry about the tests that use me. So in this case, if I have any tests that use the client and I don't have an Elasticsearch available, it will just fail exactly as I want it to. And in my particular case, it will just say, yeah, all tests that need Elasticsearch to run, ignore them. Here is something that's intimately familiar to us now. It's something that will say, yeah, clean up after yourself, delete all the indices, delete all the templates, etc., just so that the next test has another thing. You can also see that here I'm using a different scope for the fixture, because this is something that I only have to do once during the entire run of the test. Whereas this is I have to do after every single test. So this I literally just do once. Every time I execute the tests, no matter how many tests I have, let's see how many tests we have. We'll just run PyTest. And we do have quite a few tests, 361. And they all pass. We can see that if we actually stop Elasticsearch and we run the test, we'll see some of them being skipped. So these are skipped. We see that there are 287 tests that didn't require Elasticsearch and they ran just fine, but we had 74 that had to be skipped because we didn't have any Elasticsearch. So every time I execute the PyTest here, I only run this fixture once because its scope is the entire session, whereas this fixture gets run every single time it is needed, and so on and so forth. In the end, if I look at the actual tests, so let's actually look at some of the simpler tests that are using Elasticsearch. You can see that it's just requiring the data client, which is a fixture. We can have a look into how it looks. So it's right here. And it's a fixture that requires the client and actually creates an index and loads data into it. Okay. So here I have some data in Elasticsearch, which means if I actually do a search, I should get back 53 results. That's what this test is. And you can see that the test is super simple. It just focuses on the things that it needs to do. It doesn't bother itself about, yeah, I need to load the data in first. I need to make sure that they're there so that then I can run this command. No, that's all abstracted away here in my fixtures. And of course, I have other things here that if I do some filtering, I only get 2 results, etc., etc. Okay, so I think that's pretty much it from me for like a brief overview into testing and how to think about it. The things to remember is don't just try to test the code as it is. Always ask yourself, how can I structure the code so that my work in tests is easier? That's the first thing. And second thing is use fixtures and setups and all of these things to make sure that your tests only include the necessary things. Those 2 things go hand in hand. And if you actually follow them, if that's a way of thinking that you adopt, you will have much better experience both testing, but also just writing regular code. The often used excuse is I cannot do testing because I don't have time to do tests. To me, that's always a signal that that person doesn't know what they're talking about. Tests don't slow you down. Writing tests is not an additional work. It's part of the code. And actually, without the tests, the development itself will take longer, because then you have to think hard and long about how to structure a code, and you need to think, and that's a painful process. So instead, if you use tests, the tests will guide you through how to structure your code, and also provide you the confidence in the future that no matter what you do, even when we have a lot of code here, I can perform any change that I see fit, even when I don't know the code base. And as long as the tests pass, I am relatively safe. And finally, there are other kinds of tools that are associated with PyTest or testing in general. For example, one of the super useful ones is coverage, which kind of tells you which part of your code was executed during the test. So in this case, I see that I have 84% coverage, which means 84% of my code was actually executed and tested. If I run Elasticsearch, because right now we're still skipping the 74 tests, I should be able to see more of the code being tested. And I could always ask, oh, we need to wait for the Elasticsearch to come up. So I can always ask the next step, and which is which parts of the code, which lines weren't touched, and I sort of know that that part of the code, I don't want to know whether it works or not because I don't have a test for it. So always an important information. So let's see, I haven't checked my coverage in a long time, so I'm curious myself. Oh, 94, so that's not bad. But also you can see I don't have 100% code coverage. It is definitely nice to have, and for some of the more important pieces of the code, it's important. But overall, some trivial pieces of code you don't necessarily have to test. Just because some project has 100% code coverage doesn't mean that it works. So it's just a nice information, but don't be too focused on it. Okay.
Cool. Thank you so much. We have some questions. I've seen several questions in the Slack channel. You can also post like more questions in the chat in Zoom, or obviously then just shout out. Let me read the question in the channel. Petr Messner, I thought people say tests should be without database. Let's assume Elastic is a database.
Okay. What do you mean assume? So yes and no. There are different kinds of tests. Some are unit tests, some are integration tests, some are performance tests, some are load tests, some are fuzzy tests or smoke tests, etc. And all of these different tests, the way that they differ, the definition of those terms pretty much dictate how isolated they should be. So in this case, Petr was talking about unit tests. And for that, 100% correct, unit tests should not reach out to any external system. The only thing that the unit tests are kind of allowed to call or execute or touch is one piece of the code. Opinions differ whether that's one method or one class, etc., but it cannot reach out anywhere else. So that would be our first test that we created together. That would be the get neighbors part. That was a perfect unit test. But in reality, unit tests have completely different purpose than, let's say, integration tests. Unit tests will help you with structuring the code and developing the code, whereas integration tests will tell you that your code works as expected end to end, or maybe not end to end. That would be an acceptance test. But as you can see, it gets tricky. My advice is don't worry about this. Like, it is an important distinction for a lot of theoreticians, and there is some value to it. For example, you saw that my tests are split into two different things, where one bit got skipped when I had no Elasticsearch. Those were the integration tests. And also you saw that there were only 74 of those, whereas overall I had over 360 tests. So that kind of gives you the idea of how to structure it. So what I would say is focus on the unit tests when you're writing code, because that's when they are valuable. But to make sure that your code runs next week and the week after, integration tests are much more valuable because they combine all of these things together, and therefore give you a much higher level of confidence. On the other hand, what they don't give you is specificity. They will just tell you it's broken, but not where, because they're more complex. They're by definition more moving parts. So that's where you then turn to your unit tests. So that's why I always say that unit tests are great for development and for debugging, whereas integration tests are great for what we would call regression testing. Make sure that the code still works as it did before whatever changes we were trying to make. So two different things. But again, the important part is don't worry about it too much. As long as you test, as long as you're writing tests, you're better off than without it. There is an infinite depth we could go in this discussion, but at some point it kind of loses importance. So yeah.
Cool. Next question. Also in Slack, Yeti Barton is asking how fast the test should be. Is 30 seconds okay for all the tests to run?
Perfect question, especially after the discussion that we just, after the previous question. Different tests, different runtimes. For example, for Elasticsearch, like not the Python library, but Elasticsearch itself, we have some tests that run 2 months. Because that's what we need to test. Like, because some people make the assumptions, Alish, that Elasticsearch is a database. So we need to make sure that it acts that way. So we need to make sure that if you put Elasticsearch on 200 nodes and you hammer it for 2 months, it will still work. So that's a long-term sort of performance test that we run, and it's still a test. And obviously, we don't run it for every single commit or every single time you want to make a code change. That would be ridiculous. But we run it before every release or every major release, etc. We have another set of performance tests that we run every night that runs a few hours. So the answer to that question is it depends. Generally, you need to have a meaningful set of tests that you can run without having to take a coffee break. So 30 seconds, great. But that could just be a subset of tests. In my example that I just showed you, I could easily just run the unit test every time, and it finishes in 5 seconds. That's perfect. And then let's say after I finish a meaningful chunk of code, I will run the whole thing, and let's say that takes 30 seconds or 5 minutes. That's fine. So always consider how you're gonna use it, and you need to adapt the tool to it. If you have tests that run 2 hours, nobody's going to run them, which means you need a machine, you need a process that will run it for you in the background, and nobody has to wait for it. It will just run there, and if something goes wrong, it will tell you. That's continuous integration. There is a plethora of tools that will allow you to do that, but that's a little bit, well, a lot outside of the scope of this talk. But don't be afraid to write slow tests. Just make sure you have a way to run tests without those. So just run your fast tests. And by the way, again, PyTest has tools to do this, where you can select particular tests. You can select the test that only the test that failed in the previous run, et cetera, et cetera. There's a lot of power in that tool that allows you to do this, because this is definitely a very common problem. Does that answer your question?
Yeah, totally. At least like not mine really, but okay. Next one. Again from Peter. What if everyone forgets to run tests all the time and breaks our code? What can I do?
That's a very leading question. Objection. So yes, you should automate this. Again, not something that you need to be concerned when you're starting, when you're first writing your first tests, but eventually, if the tests are not being run, they don't matter. So you need to make sure to enforce the running of them. For example, you can have nowadays on GitHub, you can just use GitHub Actions to make sure that every pull request is tested, and nobody's allowed to merge it until the tests pass in that pull request. Or you can, as I said, you can use some other continuous integration tool to run the test in the background, and then ping back the people who broke the code, and they don't get any bonuses or something similar. Terrible idea, but you get the point. So just like anything else that can be checked by a computer, it needs to be enforced. The same would go, by the way, for code style. Like if you decide to use code style, you should enforce it. So if somebody checks in a code that doesn't conform to the code style, it will fail. And this is for 2 reasons. First of all, to keep the code consistent, which is super important. But to me, the more important is the second reason, which is you don't want people doing these things. You don't want me talking to Alish that his code sucks and this is how it should look instead. that needs to be done sort of, if at all possible, in an automated way, so that a computer yells at Alish, so that we can still go out for a beer and not have to talk about, you should really write your code better. Like, I was really disappointed with you the last time, or vice versa, of course. Usually that's the case, but.
Okay, cool.
Okay.
Thank you so much. There's one last question that I see in the channel, actually, on the chat. Is skip function provided by PyTest?
Yes, it is. It was from PyTest import skip, then you just call it, and it raises a special exception, and all of that happens. Again, this depends on the tool that you're using. If you're using PyTest, then there is a skip function. Otherwise, there is a skip test exception that is actually part of the unit test framework that's built into Python, etc. So each of these tools that you choose have a way to skip tests. In PyTest, yes, there is a skip function that you just import.
Thanks so much. That's all from our chats and Slacks, rooms, or whatever. Do we have any shout outs in the room, or maybe if you don't feel comfortable asking English? Je tu někdo, nějaká otázka doplňující? Zavrťte hlavou.
Ještě tam je jedna na Slacku.
Můžeš ji přečíst? Nevidím, počkej. Okay, how to be sure, or at least increase the probability. You covered the function logic by your test. Ask from John.
Okay, so multiple different ways. That's always going to be my answer to any question. But I showed you the coverage and how it works, and that it tells you which part of the code is covered or not, which part of that is touched, and you can go beyond that. You can, for example, do what we call a branch coverage. So all the different paths through the code, if a code has any branches like ifs and loops, etc. So essentially, all the different combinations, which lines could get executed, which ones were covered, and which ones were not. So again, there are tools to measure all of these, and I always give them together with a warning that the tools are great, but you have to really, really understand what they're doing, because otherwise it's too easy to just optimize for those numbers as opposed to optimizing for good tests, because those are sometimes quite the opposite, different things. So if you're interested in something like this, you can look into code coverage. On top of that is branch coverage, which is a more advanced thing. And again, PyTest has plugins for all of these things. As we just saw, you can even generate pretty HTML reports. And there are services out there that allow you to track this over time. This is, by the way, again, if you have something like a continuous integration, some robot that runs the test in the background, one of the things that they should check is that the coverage doesn't go down, because that essentially means that somebody is adding code that is untested. That should never happen. Coverage should stay the same or go up, because for every code that's being added, tests should be added as well. So yeah.
Cool, thanks. There's last one I can see. It's more like a comment. Honza forgot to mention how PyTest overrides the standard Python's assert. Smiley face.
So first of all, I did not. I mentioned that. Just because you are not paying attention doesn't mean I didn't say it, Ondro. But yes. So PyTest has some clever tricks to give you a much nicer error message than the generic assert. We kind of saw it when I ran the test manually. When I put it into the if name equals main and I ran the test, I got a little stop there and it didn't say anything. PyTest actually hacks the Python itself to inspect what's going on inside the assert statement and tries to give you a much nicer information. For example, in our case, when I tested the is 00 in neighbors, it will tell you, yeah, I was trying to look for 00 in this thing and I didn't find it. So it gives you much more detailed and much nicer error message. Not to mention it's actually printed in color, which is always nice. And it gives you the proper traceback and all of these things. So yes, good point.
Anyways, that seems like that's all, unless someone has a question like directly from Zoom audience. Feels like we're done. So yeah, I like whatever we do on Slack, like you're all muted. So
yeah, everyone can unmute themselves and try to clap their hands now.